Today we are going to be talking about slope. So slope is a type of rate of change, and a rate of change is a ratio that shows how one variable changes with respect to another. This is called slope when we are talking about a linear graph. So a linear graph is a straight line on a graph. Slope is denoted by the variable m, and it is written as a ratio of the vertical change, which is called rise, over the horizontal change, which is called run. So this is the x and this is the y and this is the x if you're thinking about it on a graph. And it's constant for any 2 points on a line. So a linear graph that has a slope will be the same for these points as it is to these points as it would be to these 2 points. And it's written as a fraction in its simplest form. There are 4 different types of slope. One is positive slope, and that is when the graph is increasing. There is negative slope, so the graph is decreasing. Zero slope, so when m is equal to 0, means that the graph is not changing, positive or negative. And then undefined slope is a vertical line that has no change. So to find slope on a graph, you're going to count the vertical change between the 2 points. That is your rise. So we know that slope is equal to rise over run. So the vertical change is the rise, and you put that over the horizontal change, which is the run. If it is a negative slope, so if it's going down from left to right, that means it's a negative slope. Then you're going to put a negative sign indicating that's a negative slope. So we're going to do these 4 examples that are on your notes. So in this first example, we're going to count the rise. So from this point to this point. So that is 1, 2, 3, 4, 5, 6, 7. So the rise is 7 over the run, which is the vertical change. So it's over 1, 2, 3, 4. 7 over 4. And that is written in the simplest form. Let's do another example. So in number 2, the change in rise is 1, 2, 3. Over the change in the run. So the horizontal change, the points are 1, 2, 3, 4, 5, 6, 7, 8, 9. And remember, it is going in a negative direction or decreasing from left to right. So that means that the slope is negative, and we can simplify this. So negative 3/9 simplified is negative 1/3. Okay, example number 3. So the rise between our 2 points. There is no rise, right? It is a horizontal line. It does not go up or down between the 2 points. So the rise is 0. And the run, it's over how far apart are they horizontally? 1, 2, 3, 4. So it's 0 over 4. And if we simplify that, that's 0. So remember, this is an example of a 0 slope because it is a flat horizontal line. And then our last example, we're going to count the rise between our 2 points. So it's 1, 2, 3, 4, 5 over, and the run, right, it doesn't change from left to right. So our run is 0, and that means our slope is undefined, right? You can't do 5 divided by 0, and this is an undefined slope. So now I want you to pause this video, and you can do examples 5 to 16. So slope can be determined by a formula if you're given two ordered pairs. So in these examples, we were given the graph with what points we were counting the rise and the run. And using our slope formula, we can use our 2 x and y coordinates, so x1 and y1 and x2 and y2, to also find the slope without graphing it. So we know that it is rise over run, graphically, and we can solve it algebraically by knowing our slope formula. So slope is m, and this is equal to y2 minus y1 over x2 minus x1. So let's do some examples. The first example. So you want to determine which one's going to be your first set and your second set of your ordered pairs, and then which one would be your x1 and your y1 would be on your first set of ordered pairs, and your y2 and x2 would be on your second ordered pairs. So I would like to make the numbers, I like to subtract the numbers so that it's the larger number by the smallest number. So I will make in our first pair, this one will be our x2 and our y2, because our ordered pair here is larger than our ordered pair here, so it just makes subtraction easier. And 1, 1 will be our x1 and our y1. So first I'm going to be doing my formula for a slope, which is m is equal to y2 minus y1 over x2 minus x1. And in our first example, our y2, we said, is going to be our second order pair, which is here. And our y2, right, that just means our y. So our y in this ordered pair is 3. So I'm going to do 3 minus our y1. And we said our y1 is going to be in this ordered pair here, and it's our y. So the y is 1, so 3 minus 1 over x2. This is in this ordered pair. Our x2 is 4 minus our x1 is in this ordered pair, and it's 1. So now we can do our solving. 3 minus 1 is 2, and 4 minus 1 is 3. So in this example, our slope between these 2 points is 2, 3. And if we were to graph it, so let's say we graphed each of our ordered pairs. And so we graph 1, 1 and 4, 3. Oops, make this a straight line. Okay, so if we were to do it like we did before and we did our rise over our run, our rise would be 2 over our run, which is 3. And that's our slope. So here we figured it out graphically, and here we figured it out algebraically. Okay, let's do our second example. So we want to find the slope between -2, 4 and 10, -2. So I'm going to make our first one our x2 and our y2, and our second one will be our x1 and our y1. And again, you can pick either one. You'll still get the same answer. The most important thing is to make sure you're paying attention to your signs. So we're going to do y2, which is 4, minus our y1, it's -2, over our x2, which is -2, minus our x1, which is 10. So 4 minus a -2 is 6. -2 minus 10 is -12. If we simplify, 6 over -12 is -1/2. So I would have gotten the same answer if I had done this is my first pair and this is my second pair, as long as I'm paying attention to my signs. Okay, let's do example number 5. So you can pause this video and do 3 and 4. When you're done with 3 and 4, come back to the video and we're going to start with example 5. So for 5, I'm going to make the first one my x2 and my y2, and my ordered pair 3, 9 will be x1 and my y1. So y2 is 9 minus my y1 is 9 over, this is my slope m, over x2, which is 5, minus y2, or sorry, my x1, which is 3. So now 9 minus 9 is 0, 5 minus 3 is 2, 0 divided by 2 is 0. So our slope for number 5 is 0. And what that would look like, right, if I were to graph it, just to bring back your knowledge from what we learned about finding slope graphically here, right, if I were to graph my points, okay, so 3, 5, 9, and 3, 9 is here. That means that if I were to connect to my points, I'm finding the slope between these 2 points here. It's 0 because it's a flat horizontal line. So it makes sense, right? This is what it looks like graphically. We were able to solve this algebraically using our slope formula. So our slope is 0. And let's do one more example. So we have negative 7, 8 and negative 7, 5. So I will make the first one my x1 and my y1. Again, it doesn't matter which one is which, as long as you're paying attention to your signs. And this one, my x2 and my y2. So my y2 is 5, minus my y1, which is 8, over my x2, which is negative 7, minus my x1, which is negative 7. So 5 minus 8 is 3. Negative 3, negative 7 minus a negative 7. Those cancel out. It's 0. And negative 3 divided by 0, anything divided by 0 is not possible, so this is undefined. So remember, that is when we have a straight vertical line. And if we were to graph it, here I'll graph it on my same one. Okay, if I were to graph it, so negative 7, 1, 2, 3, 4, 5, 6, 7, 8. And then negative 7, 5 would be somewhere around here. If I had to connect the 2 points, that should be on negative 7. If I had to connect the 2 points, and I wanted to find the slope between these 2 points, which is what this is asking me, it's undefined because it does not have a slope. It is a straight vertical line. So my answer for number 6 is undefined. So now I want you to continue doing the examples 7 to 10.